Hello, and today we will be going over the valence bond theory for ClBr2F. First, we can start off by creating a Lewis dot diagram for the compound. Cl has 7 electrons, Br2 has 14 electrons, and F has 7 electrons combined to create a total of 28 electrons. Knowing this, we can now construct the Lewis dot diagram. We have Cl as our central atom, and we have Br. We can connect the two Brs and the F with a single bond for each one, and then we add the surrounding electrons around the Br, the F, and the other Br, and then we can add 2 lone pair electrons onto the Cl to combine to create a total of 28 electrons for the entire compound. Next, we can construct the Vesper diagram for ClBr2F. Cl is the central atom, and we have Br and F attached with single bonds, and the electron pairs on them, showing that they are all in the same plane. The lone pair on the top right is connected to the Cl central atom through dashes. The dashes signify that that lone pair is going into the paper, or into the screen in this case, away from us, and the lone pair with the wedge on the bottom shows that that lone pair is coming towards us. In addition, the arrangement of electron pairs for this particular compound is trigonal bipyramidal, but for the geometry of this particular compound, it is actually T-shaped, and you can see that as T-shaped, and you can see it also by the angles. So the angle on the Br to the Br, as you can see, is greater than 180, and this is due to the lone pair bonding pair repulsion is greater than bonding pair repulsion, and because of this, the angle is bent, showing that the angle kind of shifts towards the F, is bent towards the F, and in the angle from the Br to the F, you can see that the angle is less than 90 degrees, once again showing the bentness of this geometry. Here we have an atomic orbital, and you can still see the same almost sort of structure with the T-shaped geometry of this compound, and you can see Cl is still the central atom with a Br on top and on the bottom, and F on the left. And then if we go on to the next slide, here we can see the atomic orbital overlap. You can see the sp3d overlap with the 4p orbital of the bromines right here and right here, and you can also see the sp3d overlap of the F and its 2p orbital right here. It is also important to note that these diagrams do not show the lone pairs. Next, we can go over the box diagram for ClBr2F. First off, we have the ground state of our central atom, which is Cl, and we can see that it has 7 electrons, so it goes to 3p. But in order to get it to its excited state, we will have to add energy, and then we will also have to promote this electron right here to go to 3d. This is essential for hybridization. And next, we will hybridize, and so this goes, hybridization is in sp3d, and then the blue represents electrons coming from the Cl, and then these two right here, these represent the lone pairs, and this is also found on the Vesper diagram right here. And then the latter 3 blues, in their spaces, they still need to be filled, and in order to be filled, they will get it from the surrounding molecules. So then, in terms of the Br, which is in the 4p orbital, they will put an electron right here, and they will get another electron and put it right here. And for the F, this F is actually in the 2p, not the 4p, and we'll get 1 electron right here and move it right here. And that will complete the hybridization of ClBr2F. Here we can see a model kit for the compound ClBr2F. The purple represents the Cl central atom, and then you can see those two beige parts sticking out. Those represent the two lone pairs. As we can see, one is coming towards us and one is going away from us, as we previously mentioned. The gray parts represent the single bonds, and the two light green circles on the gray bonds represent the two bromines, and the green molecule represents the fluorine. And for last, we can go over the contour diagram for ClBr2F. So first off, we have Cl as our central atom, and also this has 5 electron groups, so that means we have 5 sp3d orbitals attached to it, and so we have drawn each one of them in the green shape that was drawn. They are all also labeled. We also have 2 electrons at the end of them, and so as you can see, there appears to be overlap between the 4p orbital Br on the top and on the bottom, and that is because they are bonding pairs, or they are bonding, and the same goes for the 2p orbital of the F with the sp3d orbital on the left. In addition, all of these bonds are also sigma bonds, and once again, these all represent bonding pairs. As for the 2 sp3d orbitals on the right, you can see that they are not bonded to anything, and that is because these represent the lone pairs that are attached to the Cl. In addition, we can see that the angle between the Br and the Br is greater than 180 degrees, and this is due to the LP-BP repulsion is greater than BP repulsion, and so this sort of causes the angle to be bent and go towards the F. In addition, we can also see that the Br to F angle is also less than 90 degrees. In addition, this once again represents the T-shaped geometry of this compound.